Assalamu alaikum. Welcome to the third lecture of Material Science, MAIE 3161. We will start by giving you what we are going to cover today. We will do a brief review of lecture 2 so that you are mentally connected. Then the topics that we will cover, new topics that we will cover today are composite materials, electronic materials, nanomaterials, and biomaterials. Towards the end of the chapter, we will give you a few slides where I have prepared the slides for you, but you do a small reading assignment, and that will be hopefully the end of chapter 1. So this is a quick look of what we did in lecture 2 last time. We were talking towards about the material science and engineering. What is the difference between them? What is the interrelationship between them? Further, that in the innermost circle there are basic sciences, in the outermost circle there are applied sciences and engineering, and material science and engineering is a bridge between these two. Then we started talking about actually the types or the categories of different materials that are there in engineering. Of course, what we don't mention is the class called non-metals like iron and nitrogen and so on. So the first major category, we are talking of metallic materials. What is their nature? What are their properties? We continue about metals. We talk of ferrous and non-ferrous metals, superalloys, biomedical applications, nanotechnology, powder metallurgy. We show you examples of very advanced engineering products where high strength alloys and superalloys are used. Then we go to the next category of materials called polymers, or also called plastics. We tell you their nature and their properties. We tell you about blending polymer with another polymer to get better properties. We show you CDs and DVDs, which are a very common application of polymeric materials. A figure giving how the cost of the different types of materials per unit volume has been changing over the years from 1970s to 1990s. The third category of materials known as ceramics, chemical bonding of metal to non-metal, their properties, their applications. More modern ceramics known as engineering or structural or advanced ceramics. An example of a future automobile engine which is turbocharged for very high performance, where ceramic materials can be used for a very long time reliably. A future ball bearing, something which is used very commonly, but if the balls are made of ceramic materials, then their performance and life will be very high. The fourth category, which is not the natural category, the natural categories are metals, polymers, and ceramics. Composites are a new category because they are a mixture of any of the previous three. So we talked about what are they, how are they made, what are their advantages and their applications. And this was the last slide of the last time. We were showing you aeroplane body, and the different types of shades are there: carbon-based composites, carbon aramid-based composites, aramid-based composites, glass type of composites. So we were showing you that a lot of composites are now being used. So this was the end of the review, very quick review of the previous lecture. Now we start with lecture 3 for today. So I am again giving you an example. This is, I don't know if I have mentioned earlier. You see, in my lectures, there is one basic book that I am using, which is Smith and Hashmi. There is another basic book, which is Callister and Rethwish. So a lot of slides are a mix-up of those two already. But from time to time, for modern developments and new things that are there in the world, I go to other sources. So some of these slides and some of these pictures and so on are not from any of the books, from other places. And I would encourage you to also do that. So here we are again just showing you that you see this is the body of the aircraft and how the seats are made and how the supports are made. And if you can look inside them, then you will see that there are a lot of things which are superalloys and metals, but there are a lot of things which are composite materials, lots and lots of them. So I am just giving you an example that even in one product there are hundreds of different types of materials used, and many of them are composites here. Similarly, I am giving you the example of a car, right? This is a normal car nowadays, right? This is 2016 Volkswagen Golf. And again, right, multiple composite materials. So here you can't read very clearly, of course, but if you search for this picture, right, you write this 26 Volkswagen Golf and search for images only, or write composite materials in Golf, and then you will see that, you see, we color coding this, that there are tens of 20s of different types of composites which are used in the body, in the seat area, in the steering, in the wheels, and so on and so forth. So composites now are rapidly changing basic metals and basic polymers, because they metals are very strong but they are heavy. Polymers are much more flexible but they are not as strong. But when we make a composite mixed of metals and polymers, then we get good strength properties, good ductility, and easy manufacturing, and so forth. Now all the basic categories of materials are finished. You see, non-metals, as I told you, we have not discussed because non-metals are non-metals. But apart from non-metals, the three basic categories are metals and alloys, polymers, and ceramics. And the new version is composites. So all this covers all the types of materials. Now the types of materials that we are going to tell you are not the major material type, but by applications. So that is what we are saying, that not major material type, but advanced engineering applications. So of course, advanced engineering applications, the most common application that you know around the world is electronics, right? Electronics. All your phones and computers and laptops and everything in the world has electronics now inside it, right? The most common electronic material is what? You already know it, silicon. Can anybody tell me the other material which is basically used for electronics? Anybody? I don't know. There is another metal called germanium. So germanium and silicon are the two materials. Germanium and silicon are the two materials that are used mostly in electronics. So this is the basic material, but its electrical characteristics can be changed by adding what we call impurities here, or we can call additives, right? We select certain additives, we mix it with silicon to give you the electrical properties that we need. And of course, huge development through the use of silicon and other semiconductor materials in solid state and microelectronic devices and so forth. So this you know a lot. If I try to remind you of the table where we were saying that in the Earth's solid crust, what are the materials that are there? So there was about 5% of iron, but if I remember, there was about 8% or more of, or I don't know, 11% of silicon, right? So that for the future, you can have lots and lots. Can anybody tell me that in the natural materials, silicon is formed in which form? Silicon is found as which natural material most commonly? Anybody? The name silicon, does it give you any other idea? Yes, if anybody has guessed, sand. You understand sand? All across the world, wherever you go, to every beach, you go to every desert, there is sand. Sand is made of what? Sand is made of silica. Silica, right? Silicon oxide, silicon dioxide, silicon trioxide. So all over the world, wherever there is sand, and there is hundreds of millions of tons of sands everywhere, it is silicon, right? So if we do the extraction just like we do for iron and so on, then we can separate silicon from there. Now, examples in electronics, silicon chips. You know there are chips inside every electronic thing, transistors and so on. Now transistors are old things. Now they are called integrated chips, IC chips, right? You know that in your phone there is a chip, in your computer there is a chip, and so on, right? And of course, when they are made for chips which are called integrated circuits, ICs and so on, then they are used in computers, integrated circuits, satellites, computerized robots, any other computer applications and so forth. All this is electronic. Now, just a basic question. What is the difference between electrical and electronic? See, you have heard of these two words, you have even done courses about them. But you see, that is why I want to keep on pushing at you that these are basic terms. You say this device is electrical in nature, and you say this device is electronic in nature. Is it the same thing? Are they different? Of course, electricity is flowing. Of course, electricity is flowing. Electrons are flowing through the wire, therefore electricity is there. But when electrons are flowing, why do we call it electrical one time and why do we call it electronic the other time? The main thing is in the control system. The main thing is the control system. You see, the devices are called electromechanical basically. You see your fan in your house. You know a fan on your ceiling at the top. There is a fan which rotates and gives you air. Everywhere there is a fan. This is electromechanical. You take electricity and you convert it into electromagnetism and so on, so that motion is there, movement is there. So electromechanical. You have your fridge where you cool the things. You have your AC, which is the other type of cooling the atmosphere. They are basically electromechanical devices, and there are many machines around the world which are electromechanical. Mechanical means there will be moving parts, and electromechanical means you will use electricity to run them. So these are electromechanical. But when we start controlling them automatically, controls, then we put electronics inside them. Even in your fridge, for example, the whole fridge is electromechanical, but there is a small control there, right, through thermostats and so on, which automatically starts running the compressor and then shuts it off for some time, that enough cooling is there. So that auto control is through an electronic chip, right? Whether it is your AC, whether it is your fridge, even though the whole machine is electromechanical, the whole machine is not electronic. It is electromechanical, but the control system is electronic. But then there are machines like your laptop, like your computer, like your phone, which are totally electronic. The whole machine is controlled by a circuit board, and all the circuit board, there are lots and lots of different electronic things and so on. The main one, of course, is an integrated circuit called a chip, the main chip and so on, right? So you should know that electronic means there are control systems which have silicon material inside, and there are chips and transistors and integrated circuits there. Electromechanical means there is general wiring and motors and those type of things, right? So just for your knowledge, we are talking that you should know a difference between these two very clearly. So here we are just showing you a microprocessor, a chip, right? A microprocessor, you see, there was initially, if you know your electrical fundamentals, there was initially things called tubes, right? Then they were changed into transistors, right? Each transistor has an NP junction, a negative positive junction. Then they started integrating them, making them smaller and smaller and smaller. So now here in this microprocessor, there may be thousands or millions of chips. So now it is an integrated circuit, but this is basically a chip.